There are still 5 more physical properties of minerals that we are going to discuss. Specific gravity. It says here that the specific gravity of a mineral is the ratio of its weight of an equal volume of water. Specific gravity of a mineral depends upon the weight and spacing of its atom.
Also known as SG, is a measurement that determines the density of minerals. Two minerals may be the same size, but their weight may be very different. The specific gravity of a mineral determines how heavy it is by its relative weight to water. The specific gravity value is expressed upon how much greater the weight of the mineral is to an equal amount of water. Water has a specific gravity of 1. If a mineral has a specific gravity of 2.7, it is 2.7 times heavier than water. Minerals with a specific gravity under 2 are considered light. Between 2 and 4.5 are average, and greater than 4.5 is considered heavy. Most minerals with a metallic cluster are heavy. The specific gravity may slightly vary within a mineral because of impurities present in the mineral's structure.
Cleavage. It is defined as the tendency of a crystallized mineral to break along certain definite planes, yielding more or less smooth surfaces.
Cleavage is related to the internal structure of a mineral. The cleavage plane area is always parallel to some faces of the crystal form of a mineral. It is also described on the basis of perfection or the degree of easiness with which minerals can split along the cleavage planes.
Fracture. The fracture of a mineral may be defined as the appearance of broken surfaces.
The characteristic of a fracture is when it marks left when a mineral chips or breaks. Cleavage and fractures differ each other in that cleavage is the break of a crystal face where a new face is formed, that resulting in a smooth plane, whereas fracture is the chipping shape of a mineral. All minerals exhibit a fracture, even those that exhibit cleavage. If a mineral with cleavage is chipped a certain way, it will fracture rather than cleave. There are several terms to describe the various mineral fractures. Conchoidal. The broken surfaces show concentric rings or curved surface. Even fracture. When the broken surface is smooth and flat. An even fracture, when the mineral breaks with an irregular surface. It is a common fracture of many minerals. And the last one is splintery structure. It is when the mineral breaks with a rough texture.
Tenacity. Tenacity describes the reaction of a mineral to stress such as crushing, bending, breaking, or tearing. Certain minerals react differently to each type of stress. Since tenacity is composed of several reactions to various stresses, it is possible for a mineral to have more than one type of tenacity. The different forms of tenacity are: first, brittle. If a mineral is hammered and the result is a powder or small crumbs, it is considered brittle. Brittle minerals leave a fine powder if scratched, which is the way to test mineral to see if it's brittle. The majority of all minerals are brittle. Second, sectile. Sectile minerals can be separated with a knife, much like wax but usually not as soft. Malleable. If a mineral can be flattened by pounding with a hammer, it is malleable. All true minerals are malleable. Next is ductile. A mineral that can be stretched into wire is ductile. All true minerals is also ductile. Flexible but inelastic. Any minerals that can be bent but remains in the new position after it is bent is flexible but not elastic. If the term flexible is singularly used, it implies flexible but inelastic. Last one is flexible and elastic. When flexible and elastic minerals are bent, they spring back to their original position. All fibrous minerals and some acicular minerals belong in this category. The last physical properties of minerals is form. Form is the internal atomic arrangement of a mineral which is manifested outwardly by development of geometrical shapes or crystal characters. There are three atomic arrangements of minerals or form that I will give to you. The first one is crystallized. When we say crystallized, it is a well-defined crystals with a perfect cleavage that is indicative of perfect atomic arrangement. The second one is crystalline. When we say crystalline, it is a development of small grains and virtually incipient crystals. And the third one is amorphous. Amorphous minerals are those that have no detectable crystal structures. And that is all for the physical properties of minerals.